Unit 8, Part 4. At the end of Part 2, I was talking about double negation, pointing out that this inference on the right over here is not a legitimate application of double negation, right? The two negation signs are not contiguous, so these were all valid applications of double negation. This is not. What is a valid application, or what rule should I use on a formula like this? De Morgan's rule. Okay, and De Morgan's rule is very crucial. You must, the use of De Morgan's rule must be pretty automatic, especially as a top-down thing, right? Whenever you see a negated conjunction or especially a negated disjunction, no matter how complex, right? And I'll go through examples where you see quite complex applications of De Morgan's, right, where the subformulas are themselves quite complex, but the overall form, again, you've got to focus on the overall form, and if you see that the overall form of some premise you have is like this, a negated disjunction, especially, you should perform De Morgan's right away, and what will result is a form which will be, it will give you, what will result is a formula which, you'll see, gives you more things to play with, more formulas to use in trying to derive more stuff. In fact, I say that from now on, this, right, what is this? This is a negated disjunction. So, right, leaving the P and Q out, that's the form, right? So you have to be able to see this when this is, you know, a big long A biconditional B, hook C, and this disjunct is not, brackets, 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 blah, 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 right? If that's a legal formula, if you see that whatever it is, the major operator of if it's a negation overall, and the major operator of the thing that is negated is a disjunction, if it is a negated disjunction, if that is a true description of the form of the thing, no matter how complex, always perform De Morgan's right away, if this is a premise or otherwise a formula you have derived, because look at what results. And when you see what results, this is why I think from now on I say, this is the new emoticon for the happy face. Right? This is the new happy face emoticon. Why? Because, as in here, when you apply De Morgan's, right, and I'll talk about the form in a moment, but you apply the De Morgan's here, negated disjunction becomes a conjunction, right? Not A and not B, becomes this conjunction. Practice these until it's very automatic doing this, right? And what is this form, right? This is true for every application of De Morgan's of this form. That is, every negated disjunction becomes a conjunction of two negations, but importantly, a conjunction. And what do you do with conjunctions? Automatically, it's a habit. You simplify, right? So immediately, not A and not B, right? And you've got these. You could also do A by double negation in this case, but always, right? Whenever you have a negated disjunction, there's 1, 2, 3 moves you do straight away. You do De Morgan's, which always results in a conjunction. Always when it's a negated disjunction, it results in a conjunction. And conjunctions you simplify. So 1, 2, 3, right? So that's why it's a happy face, because this might be long and horrible and ugly, right, as a whole, but you've now simplified to these two things. So this move, you'll see, you need to become quite familiar with, and it should be automatic. The rule, right, so that's what we do here, De Morgan, that's the proper application of that. These are the two forms of De Morgan, right? Just convince yourself that it's true. Be careful to note that the left-hand side to the right-hand side, right, is a change in symbol, right? What's in the brackets here is not the same as what you get on the other side. Similarly here, if it's a negated conjunction, right, a negated conjunction becomes a disjunction, a negated disjunction becomes a conjunction. So note the change in form, right? Don't fail to make the change in form. It's clearly true, right? Just convince yourself, right? You should all be very familiar with seeing the form of this thing, right? That is, distinguishing when the conjunction happened and when the negation happened, right? This is a negated conjunction. It's a very different formula from, say, a conjunction with the left conjunct negated. That's something else. That's not this. But this, right? This says, so, okay, start with the top one. What does that say, right? That's P or Q, right? So I'm negating P or Q on the left-hand side, right? So this says P or Q, or P or Q is true. Either P or Q is true. Now I'm saying it's not the case that either P or Q is true. Process that for meaning. If it's not the case that either P or Q is true, that means both P is false and Q is false, right? If neither P nor Q is true, if it's not the case that either P or Q is true, then both P is false and Q is true, right? Yes, process of meaning. It is clearly, those are clearly logically equivalent formulas. Similarly here, what is it that I'm negating, right? This says both P and Q are true, or just P and Q, both of them are true. It's not the case that both P and Q are true. Okay, so either P is false or Q is false. Yes, that's logically equivalent expression of the same thing, right? Logically equivalent formula. Yeah. If that's true, that's true. If that's true, that's true. If that's false, that's false. If that's false, that's false. And if that's true, that's true. If that's true, that's true. If that's false, that's false. If that's false, that's false, right? They're logically equivalent. So De Morgan, you have to be very familiar with it. It's often used. You need to see it in subformulas, of course. And you need to be able to apply it to very complex instances. Biconditional exchange, I mentioned biconditional exchange in Unit 7, Parts 13, 14, when I went through 7G, wasn't it? F. I did exercise 7F in Parts 13 and 14 for Unit 7, last two parts. So biconditional exchange, I'll sort of repeat what I said there, but this is the rule, biconditional exchange. If you're given a biconditional, right, P biconditional Q, so again, think it in its generality, any biconditional, right, but if the major operator of something is biconditional, you're entitled to replace it with the conjunction of two conditionals, right, P hook Q and Q hook P, okay? Or, since you can go right to left, if you're given if you're given the conjunction of two conditionals, the antecedent of one is the consequent of the other, both times, you're allowed to replace it with a biconditional. Okay, of all the rules we have, including by the end of Unit 9, when we've completed the rules, two more rules to come in Unit 9, conditional proof, indirect proof. Those are two rules involving assumptions. So most of the rules are in Unit 7 and Unit 8, all but two of them. At the end of all our rules, there is only one rule governing the use of the biconditional. There's only one rule in which the biconditional appears. Okay, so you can be pretty safe in assuming that if you see the biconditional, if you're going to do anything with it other than keep treating it as a block or as a formula with its intact as it is as a biconditional, I'll say what that means in a second. But if you're going to do anything with that biconditional, you're going to do a biconditional exchange. Of course, the result of biconditional exchange, if you have a biconditional, say, amongst your premises, right? We'll want to think about what you do when it's a premise and what you're thinking to do when it's a conclusion. That is, when you've got a biconditional in the premise amongst the premises and when you've got a biconditional as a conclusion. But if you've got a biconditional as a premise, pretty much all the time what you want to do is, if it's not going to be this situation or this situation, I'll explain in a minute, but basically what you're going to do is want to do the exchange. Notice that the result of the exchange is a conjunction. What do you do with conjunctions? You simplify, right? So biconditional exchange, you'll pretty much always do the if you've given a biconditional, since the only rule governing the use of biconditionals is biconditional exchange, you'll pretty much always want to do biconditional exchange on it. Results in a conjunction. Simplify the two conjunctions, and you've got, right, a P hook Q and a Q hook P. So with those, you'll do probably a modus ponens and a modus tollens, combining those formulas with other formulas you have, other premises you have, to break off the antecedents and consequence of these things. Okay, these are two situations you'd be in. These two examples are going to be the kind of situations you'll be in when you wouldn't actually need to use biconditional exchange, and because these will be situations where the biconditional itself, you want to keep it as a subformula to use it as you need to use it to get your conclusion, right? And this is what mirrored the situation in 7F from Unit 7, Part 13 and 14 videos I spoke about there, right? There we had a situation like this where the biconditional was, okay, start with this one. We had a situation there where we had a biconditional as a conclusion, right? But it turned out that that biconditional conclusion, we didn't have the rule of biconditional exchange then, but say you were given that proof when you have all the rules available to you, you would ask, does this whole formula as a whole appear amongst the premises, plus or minus a negation? In this case, it does, right? If you were given that as a premise, this is not B biconditional E hook G, right? And you should here think, right, you've got maybe some other premises, but if you also notice, right, you'll be able to notice that, well, just looking at the first premise, you would think, okay, I can basically get home, not all the way home, but I can almost get home if I can perform a modus tollens, if I can, right, because a modus tollens gives me the negation of the antecedent, and it's actually exactly what I need. Well, it's exactly what's the result of modus tollens with one and whatever other premise. It's going to be not, right? Remember rigor, as I was just talking about in Part 3. That would be the result of modus tollens, and then I can infer that by double negation, okay? And so here, you've got, so that would tell me, do I have or can I get the negation of the consequent to do the modus tollens? Here it is, or maybe you arrive at that, you bust it out. So the point is, in this case, you would not use biconditional exchange there. But if you don't have anything like that in the premises, if you've got a biconditional exchange that's a conclusion, right? So that's the conclusion. You want to work backwards like this. You say, okay, I'm probably going to get that biconditional exchange by doing a BE, having derived the two conditionals separately, right? So working backwards, that's probably going to be my second last line when I can join these. And what I need to get home is somehow derive this B hook A by itself, somehow derive this A hook B by itself. Okay, very quickly. Here's the other one, right? If you've got a biconditional as a premise, you think most of the time I'll do biconditional exchange, but not in a situation like this, because the only use you need to make of this is keep it as a whole, use it in the modus ponens to get E.